Chapter 5, Section 3, problem number 23. The useful life of a particular make and type of automotive tires, normally distributed with a mean of 57,500 miles and a standard deviation of 950 miles. A. Find the probability that such a tire will have a useful life of between 57,000 and 58,000 miles. Okay, this sounds fairly straightforward here. I'm getting a little suspicious though because this is in those additional exercises to see what else is going on here. So we need to know the probability that we're going to be between 57,000 and 58,000 miles is what we're looking for. And we're given that we have a normal distribution with 57,500 for the mean and standard deviation of 950. Both of those are in miles. Always good to check the units in case they put them odd in there and we have to convert around. Alright, so again we have a general normal distribution. We need to take this to the standard normal distribution. So, and another step here, since we're doing between, this will be the same as the probability that x is less than 58,000 miles minus the probability that x is less than 57,000 miles. So subtracting off what's less than 57,000, that gives us what's between the two. And we have to transform these, so we have the probability that z is less than 58,000 minus the mean, which we're given as 57,500 divided by the standard deviation minus the probability that x is less than 57,000 minus 57,500 over 950. And this is the problem. So when you work that out, this is z less than, okay, minus 0.53. No. That's a plus, right? Plus 53. Nice probability of z is less than minus 0.53. Look at this. This is symmetric here. So these values are going to be, well, it's not going to be the same per se because it's the tails that are same. And in this first one, that's what's less than. If it were what's greater than 0.53, that would be the same value as the other. Okay, I probably shouldn't have brought that up. That just gets confusing. Let's just go back here. So if I look this up on the table, 7019 minus 2981 gives me 0.4038. So there's a 40% chance that it'll be between those values. Could be the tire lasts longer or not as long. Okay, B. This is where I think I'm going to get something suspicious here. So Hamlet buys 4 such tires, assuming that their lifetimes are independent. Okay, each of these 4 variable or 4 realizations of the variable outcomes are going to be independent. Find the probability that all 4 will last between 57,000 and 58,000. If so, the best tire will have no more than 1,000 miles left on it when the first tire fails. Okay, and there's a binomial random variable here whose value of p comes from part A. Okay, so we have, that's the tricky thing here. This takes us back to the previous chapter even. So the binomial random variable, we're looking at the number of choices of things that are taking place. So we have a binomial random variable who the probability of that taking place is the 0.4038. So P equals 0.4038. And so we need to look at what the probability is so that's the probability that it's going to be between those. So we need to say that the number that we get out of 4 is going to be 4. So that's the probability that we're going to have 4. I'll call that equal to y, since we've already been using x up above, so y is going to equal 4. Okay, I'll go back to the previous chapter and look up the calculation there for the probability. So we have n factorial over y factorial, n minus y factorial, times p to the y times q to the n minus y. Oh my goodness. So in this case, the number of trials we have is 4. And out of those trials, we're looking at having all 4 equal the values. So y equals 4. P, we're given q equals 1 minus p equals 1 minus 0.4038. So q is going to equal 0.5962. Alright, so we write all this out. This is going to be n factorial, so 4 factorial over 4 factorial, 4 minus 4 factorial, p 0.4038 to the y, which was 4, and q 0.5962 to the 4 minus 4 to the 0. Okay, so these 4's are going to cancel out. This 4 becomes a 1 because it's a factorial of 0. This value to the 4th, this is to the 0, which is this is going to be a 1. This is going to equal 0.4038 to the 4th. Multiply all that out, 0.0266. Approximately. I'm going to round that off some. Okay, so that's the probability that all 4 tires last exactly between those two values, that within that 1,000 miles of each other.